implicit differentiation. So far, the equations of the functions we have differentiated have been written in the explicit form, right? Just like y equals. So one variable is on one side of the equation and everything else on the other side. Y equals 3x squared minus 5x plus 2.
Could you say it more directly?
Well, f of x is equal to 4x minus 5 over 3x plus 2. The left side is lonely. It's only got one thing there. But some relations, especially ones you don't even study anymore, like conics, are written in implicit form. For example, xy equals 1 is expressed in implicit form. But it's very easy to isolate the y, right? I mean, so explicit form, you got xy equals 1. So what's y equal to? 1 over x, right? Which we could write as x to the negative 1, because if we want to do dy by dx, it's sort of helpful. And what is dy by dx? Yeah. Or negative 1 over x squared, right? So even though we have this equation xy equals 1, we can write it explicitly, right? If we want to graph it on your graphing calculator, it needs to be explicit. But what if we need to determine dy by dx of a relation that cannot easily be converted to explicit form? So one such example is x squared minus 2y cubed is equal to 3xy minus 7. So in that, it's not really that easy to isolate the y. It is doable, but not easy. To determine dy by dx for an equation expressed implicitly, we will use a method called implicit differentiation. I need an echo effect there. In which we differentiate each term with respect to x and then rearrange the equation to isolate dy by dx. So we're saying, you know, it's not easy to solve this for y, but if we find dy by dx for each term, it may be easy for us to rearrange the equation and isolate dy by dx. So first, we need to understand how to determine the derivative of a function of y with respect to x. So it's just using me. So what's d by dx? Derivative with respect to x of 5x minus 7 squared is... So what do we do? Why is it, wait. Oh, okay, I'm on the wrong page. That's why it's different. Oh, it's all different. What do we do? Which rule? The chain rule, right? So the chain rule says, all right, we're going to go 2 times 5x minus 7. We're going to do the derivative of the outer function with respect to the inner function. So 2 times 5x minus 7 to the 1, which I'm not going to write, times the derivative of the inner function, which is 5, right? And if we want, then we could simplify that and just write 10 times 5x minus 7. All right. Should we go across or up and down? What do you want to do? Diagonal. Because we'll go, no. We can go top to bottom, or we can go across.
Go across.
All right, across. Okay, so d by dx of f of x squared. How are we going to do that?
2f of x times derivative of f of x.
Yeah, I'm just going to use the chain rule, right? So again, right, we've got this inner function, you know, that's being squared. We can use chain rule, so it's 2 times f of x times the derivative of f of x, right? So we'll just call that f prime of x. So what are we going to do with d by dx of y squared? It's the same thing, right? I mean, what's f of x? You know, what do we often use instead of f of x? We often use y. So what are we going to do?
Y times y prime.
2y times y prime, which we might write as 2y times dy by dx. You we're going to aim to kind of isolate this dy by dx, of which we're going to have multiple parts. So d by dx of 9x squared minus 4x minus 2 is? Okay, so it's the derivative of the outer function with respect to the inner function 3 times 9x squared minus 4x minus 2 times 18x minus 4, the derivative of the inner function, which just leave like that, right? Yep. There we go. Right. If I was going to be right, that might go 3, and then the 18x minus 4, and then the 9, but you got it. What's d by dx of f of x cubed? So it's 3 times f of x squared times f prime of x, right? The derivative of the inner function. So what's d by dx of y cubed?
3y squared times y prime.
Or 3y squared times dy by dx. Okay, so basically, when we're doing this implicit differentiation, we're really just doing the chain rule. We're finding the derivative of this outer function with respect to the inner function times the derivative of the inner function. So we differentiate with respect to y, and then we multiply by y prime, right? Like, that's actually the easy way, right? It's just, okay, just find the derivative with respect to y, and then multiply it by y prime, or dy by dx, whichever form we are interested in. To differentiate, oh, we just said that, right? Determine each of the following derivatives. Okay, d by dx of 3x squared. 6x, right, it's too easy, right? Where's that? Yeah. There's no y in there, it's just 6x. Okay, don't get caught here. D by dy, the derivative with respect to y of 2y to the 4th is 8 y cubed, yeah, sorry. Right? And that's it, right? Because we're doing the derivative with respect to y, not the derivative with respect to x. But what's d by dx of 2y to the 4th? Right? Because remember, we're doing the derivative with respect to x. So what do we do, right? The easy way is just take the derivative with respect to y of the function of y. So we got 2y to the 4th. The derivative there is 8y cubed. And then multiply it by y prime. Right? Or dy by dx, depending on which form we want. D by dx of x cubed minus 5y squared. Okay, so what do we got there? It's a difference, right? So what do we do? Yeah, subtract the derivatives, okay? Do we need to explicitly state that, or can we just go straight to the answer? Straight to the answer, so what's the first part of the answer?
3x squared.
So 3x squared. Okay, and it's going to be minus because it's the difference of the two derivatives. So we've done d by dx of x cubed, right? Minus d by dx of 5y squared. We're not explicitly writing that down, but that's what we're doing. So what's d by dx of 5y squared?
10y times y prime.
10y y prime, right? Minus 10y. Okay, so just do the derivative of that with respect to y, and then multiply it by y prime. D by dx of 5x squared y cubed. Okay, so what is this? Which rule is going to come into effect? Product rule, right? Okay. So I might say, let's pull the 5, right? Okay, so it's 5 times, it's just the constant multiple rule, right? So we can pull the 5 out front, times the derivative with respect to x squared y cubed it's a product. Okay, so the product rule, and let's do this in a bit of detail, shall we? So we'll go 5 times, okay, so it's the first function, x squared, right? Let's put a 5, put that there. So it's first function, x squared, times the derivative with respect to x of the second function. So times d by dx of y cubed, plus plus what? The second function, right? So y cubed times the derivative of the first function. Okay? Now, I don't expect necessarily for you to show that, right? I mean, you can just do it. But that's what's going on, right? So we're just laying this out in greater detail. Here's what's happening, right? It's 5 times, and then look, I'm using the product rule, right? And maybe you want to write that out. You know, just makes you feel more comfortable. Okay, I'm using the product rule. Here's the expansion of that. So it's 5. All right, so what do we got? X squared times, so what's d by dx of y cubed?
3y squared y prime.
3y squared y prime. Plus y cubed times the derivative with respect to x of x squared, which is 2x. Yeah, it's about the easiest thing on the page, right? Times 2x. Okay, so what do we got? We've got 5, 3, we got 15 x squared y prime plus 2xy cubed. 10xy cubed plus 10xy cubed.
Wait, why is that 10x cubed?
Because the 5 out front,
Oh, okay.
right? Yeah, I missed that too the first time. So, 2, no wait, 10. Okay, so I'm just distributing the 5 through the 2 terms. Yep.
Where does the 3y squared go? Where's it?
So with the 5 out front,
Okay.
so 5 times 3 is 15.
Yeah.
Okay, then we got an x squared, then we got a y squared, then we got a y prime.
Oh, sorry, I didn't see the 1. Sorry.
Yeah. This one here, but
No, the one in front of the 5. I didn't see that was 15.
Oh.
I thought it said 5.
yeah, it's almost an absolute back down. Okay, now I've messed it up really. 15. All right. Next. Oh, yeah, fun times now. Okay, determine dy by dx, which means we're going to work our way through this, and in the very end, at the bottom, it's going to say dy by dx equals something, right? So we're going to work our way through, and what we're going to do is take basically the derivative of both sides with respect to x, or basically derivative of every term, right? So I'm going to go d by dx of x squared minus d by dx of xy squared is equal to d by dx of 4y cubed plus d by dx of 2x. No. Just doing it so that if you're looking back at this, you say, all right, I'm going to take the derivative of every term, right? Could have got a little more detail. Could have done d by dx of and then bracketed the left side and equals d by dx and bracketed the right side, then expanded that to this. Okay? Neither of which you would really have to show, right? So you're just basically saying, oh, that's one of these, and I have to take the derivative of every term. Right? Okay, so what do we get here? 2x. So don't put an equal sign in the lead, right? Because this is actually an equation. So only one equal sign per line. So we've got 2x minus, so we're going to have to use the product rule, right? So I'm going to do this in full detail, right? More than you would have to do if you're just doing this. But just so you have an example where you're looking, if you look back at this, you're going, all right, yeah, okay, so now I'm doing Okay, so now I'm doing the product rule, right? So minus, all right, so what do we got? It's the first term, x, times the derivative with respect to x of the second term, plus the second term times the derivative with respect to x of the first term. Okay, so that's my product rule. Equals. The derivative with respect to x of 4y cubed, which is 12y squared. And instead of y prime, we're going to use dy by dx, because that's ultimately what we're solving for, right? And I think, you know, I mean, if you wanted to and you did a y prime and you solved it all for y prime, and then in the end you just kind of erase that and wrote dy by dx. But we're going to leave it as dy by dx. So 12y squared times dy by dx plus 2. Some are easy and some are harder, right? All right, so that's equal to, no, it's not equal to. So the next line is 2x minus, okay, x times d by dx of y squared. So what's that? What's d by dx of y squared?
2y times y prime.
Yeah, 2y times y prime, so we've got x times 2y, but remember we're going to write dy by dx. Okay, because we're going to solve for that, right? So we're going to, at some point, we're going to have to get all our dy by dx's on one side and everything else, you know, but we'll get there. Okay, so it's not going to be a plus. So the minus here is going to distribute, so this will be minus y squared. And what's d by dx of x? 1. Okay, so it's just minus y squared, right? Like that's it, right? So we've got minus, and we've worked this, minus, okay, y squared times 1, y squared, equals 12y squared dy by dx plus 2. So now, we have two terms that have dy by dx, right? So what I'm going to do then is let's take this term here and move it to the right side, where it will become positive. Okay, that's why I'll move this over here, and take the 2 and move it to the left side. Okay, so let's see, what's that going to give us then? We're going to have a 2x. Okay, we're moving this, so minus y squared. We're bringing the plus 2 over, so it'll be minus 2, is equal to, okay, we're bringing this over, so let's call it now, what are we going to call it, 2xy? So we've got 12y squared dy by dx plus 2xy dy by dx. Recap. So we've taken the derivative with respect to x of both sides, which led us to the derivative with respect to x of each term, okay, using a sum and difference rule, which led us to using the product rule in one case and the chain rule for or implicit differentiation in a couple of cases. So now we want to factor out the dy by dx. So I've got 2x minus y squared minus 2 is equal to dy by dx of 12y squared plus 2xy. And in the end, our final line we want to write down dy by dx is equal to what? 2x minus y squared minus 2 over 12y squared plus 2xy. That's it. So if we wanted to figure out the slope at a point, and if you knew your xy, right, so if you knew the point on the curve where you wanted to find the slope, you just plug the xy into the right-hand side there, and you will come up with a number, right, a value for the slope. It all just builds on everything, right? Everything just builds on everything. Okay, so shall we do the right side one? We can do a little less detail now, right? So do you want to give it a shot? Start it out, see what you'll get.
So do you take the derivative of the whole side or just the individual things?
In essence, yeah, the line I didn't write on the other one was I could do d by dx of bracket x squared minus xy squared.
Okay, so
Yeah.
it is the whole line.
Yeah, so in essence, really, you're doing this. You're taking the derivative of this, right? You got three terms here, right? You got
Yeah.
this one, and this one.
Yeah,
Okay. So you could do it without all of this,
okay.
right? So you just sort of, okay, I'm doing a problem now. This is a problem in the book. I'm doing the problem. If you are writing out a problem in the book, write out the actual problem first and then start your solution, right? Like don't just, because if you go into your first line and you go back and look at it, it's like, what the heck? Like, what was the question? All right, so what do we got? We have 3 times. And then we've got a bit of that. That's 3. Okay, so if you've got a line down and look up and check and say, I agree or disagree. Oh, it ends up a Kleenex. Okay, so, so what I've done here is I've taken this, which is a common factor, and I'm multiplying it into this because in the end we have to have the term with this. It can't be part of something, right? It has to be just a term unto itself, which we now have here and here, which we're going to bring together, factor out, and then, okay, so I have to expand the left-hand side of this. Okay, now, okay, so I'm going to move this over here and the 4, so I'm going to get 9 times 3x minus 2y squared plus 4 is equal to 4y dy by dx plus, and then I've got my 12y times 3x minus 2y squared dy by dx. Okay, so we have to do a full expansion of the left-hand side just so we can get that dy by dx term by itself.
In the second line, could you go over how you got each term?
Yeah, so what I did was take this times this and then times this. So I just distributed this through the brackets.
Okay.
Okay, so it was necessary, the reason we have to expand it so that we get just the dy by dx term, right? So that we can then move this over. Now we're going to factor it out, then divide, then we're done. Not that it's a nice, you know, it's a fairly complex expression, right?
Who's better now?
Okay, now all I want to do is take the dy. I don't want to take like a 4y dy by dx. You know, say, hey, but wait, it's a 4y. Because remember, we're just trying to isolate this guy. Okay, so that's all we're factoring out is the dy by dx. And I got 4y plus 12y times 3x minus 2y squared squared. And now we can write down dy by dx, right? So 9 times 3x minus 2y squared squared plus 4 over this 4y plus 12y times 3x minus 2y squared squared. Okay, woohoo. All right, last one. So this time we actually want the equation of the tangent line. Determine the equation of the line tangent to 3x squared minus 2xy squared plus 4y equals 4 at the point 2, negative 1. Express the equation in the form ax plus by plus c is equal to 0, where a, b, and c belong to the integers and a is greater than 0. Okay. So we're going to want to do the derivative. I'm going to use y prime this time because I hate using dy by dx. Right? Just use y prime, then we'll solve for y prime. So we're just going to take the derivative of every term, right? So really we're doing the derivative of both sides, which then becomes the sum and difference, or difference and sum of the left side derivative and right side. So we got 6x minus, oh, got to use the product rule again. Right? So what do we got? Our first thing is 2x times, this first term times the derivative of the second. Plus second term times the derivative of the first plus okay, so look at that line and just say yay or nay or how or why.
So for the negative 2xy squared, do you have to do product rule for that?
Yeah.
And does it matter whether I do it as like x times 2y squared or 2x times y squared?
Maybe not. See what you get on the next line. Yep.
Why would it be negative 2? I thought you're minusing by the whole thing. You're subtracting. That's why you have negative the minus sign by the 6x.
So 6x, so it's going to be minus, right? And then, so it's minus, now I want the derivative of the expression, right? Of the 2xy squared.
Yeah, that's why I'm just confused about why it'd be
All right, let's see. So we could say minus. So we could do that. Plus. Minus, and then this will be a plus 2 if we do that. So you could do it that way. That helps. So this will be minus 4xy y prime minus 2y squared plus 4y prime equals 0. So we need to isolate the y prime. So we've got two terms with y prime, and we'll move the other two terms to the other side. So what do we do? We go 4y minus, 4y prime minus 4xy y prime equals 2y squared minus 6x. Okay, so keeping our y primes on the left and just arranging them so we've got it, because we had a positive term, we could put that one first. Factoring out the y prime, and dividing both sides. And we got a common factor of 2 all over the place, right? 2 over 2. Okay, so y prime, we've got y squared minus 3x over 2 minus 2xy. So which room do we have? Let's just go over here a little bit. Y squared minus 3x over 2 minus 2xy. And what do we want? What? Wait.
No, I got the same thing. I just have like the opposites on the negative side when you moved the
Yeah, that's fine.
So that's all good?
Yeah. So you have 3x minus y squared over 2xy minus 2?
Yes.
Yeah, it's fine. Because now what are we going to do? We're going to put in, what was the point? 2, 1?
Yeah.
It's on your sheet, it's off my thing. So we want the slope at the point 2, 1, right? So we are now going to put in 2, 1. So just say at the point 2, 1.
Negative 1.
2, negative 1? Sorry. At point 2, negative 1. So y prime will be equal to, all right, what do we got? Negative 1 squared minus 3 minus 2 times negative 1. What's that? 1 minus 6. And what do you got? 2 plus 4. Okay, so negative 5/6. Or for you, 5 over negative 6? Right.
Yes.
Yeah. So I have negative 5 over 6. You have 5 over negative 6, right? Same thing.
Yeah.
So negative 5/6. That is our slope. And we need the equation, right? So what do we got? Well, we've got the point. Okay. So here, so y minus y1 is equal to mx minus x1. That was nice. What was the point? Point was 2, negative 1. So y, let's call that y plus 1 is negative 5/6 x minus 2. So whatever, right? I mean, we got to get rid of the 6 at some point. 2, 6, Okay, so 5x plus 6y. All right, so I'm thinking 5x plus 6y minus 4 equals 0. We're done. I'm curious. I'm just going to pause. Okay, and so we've graphed the function. That's a weird looking function, man. Graph the function in red.
Functional here.
Yeah.
Is it a function?
Oh, sorry. Well, yeah, it's not technically a function, is it? It's a relation. We've graphed the relation in red and the tangent line in blue at the point 2, negative 1. And, you know, there it is, 2, negative 1. So it's kind of cool to see that, yeah, hey, look, it actually is that thing. And so, all right, anyways, so we're done.